Welcome to the deep dive.
Yeah.
We are absolutely thrilled to have you with us today.
Yeah, it's a really fascinating one today.
It is. And for this exploration into our source material, we have a very specific mission. We are going to take something that you use every single day, something that is entirely foundational to the way you live and work, and we are going to completely shatter how you think about its security.
It's a phenomenal piece of text we're looking at today. It's an excerpt titled "The Physical Vulnerability of the Digital Cloud."
Right. And it takes this ubiquitous concept, the cloud,
Yeah.
and forces us to look at the tangible structural reality of it, because we all rely on it for, well, everything. Our banking, healthcare records, personal memories.
But we rarely, if ever, pause to consider the structural fragility of where all that data actually lives.
Exactly. And tech marketing has done such a brilliant job over the last 2 decades of selling us the cloud as this frictionless, ethereal space.
Like a magical, weightless mist gently holding our photos.
Yeah. Even though logically we know there are servers involved somewhere, the branding is so effective that we tend to completely underestimate the sheer heavy industrial footprint required to keep it all running.
Which brings us to the first massive reality check from the source material.
The cloud is, quite literally, just someone else's computer.
That is the perfect starting point. The reality is that the digital economy you interact with every single day is not hovering in the atmosphere.
No, it is bolted to the ground.
It is heavy, it is loud, and it is incredibly vulnerable to physical disruption.
Okay, let's unpack this. Because to truly grasp the vulnerability the author is warning us about, we really have to spend a little time visualizing the actual physical infrastructure.
We aren't talking about a closet full of blinking routers here.
Not at all. The force describes massive, heavily fortified concrete buildings. We are talking about hyperscale facilities that span millions of square feet.
What's fascinating here is the sheer scale of the massive disconnect between what you, the consumer, experience and the heavy industrial reality that actually powers that experience.
Right.
I mean, you tap a piece of smooth glass on your phone and instantly a photograph from 10 years ago appears. You swipe a credit card and a transaction is verified across global financial networks in milliseconds.
It feels completely weightless.
But behind that frictionless piece of glass is a sprawling industrial complex made of steel, concrete, and miles of high-voltage copper wiring.
And these concrete fortresses are incredibly power-hungry. The source emphasizes this repeatedly. We're talking about structures that draw an amount of electricity that rivals entire mid-sized cities.
It's staggering.
And that brings up a really relatable analogy. Anyone who has ever run a high-end video game on a laptop or tried to render a big video file knows exactly what happens to that machine.
Oh, yeah.
Within 10 minutes, the fan sounds like a jet engine trying to take off from your desk, and the keyboard gets physically hot to the touch.
Right, the thermodynamics of computing. That is a brilliant way to scale the concept, because when a processor works, it generates heat.
Exactly.
Now take that gaming laptop, multiply by 2 or 3 million, and stack them floor to ceiling in a warehouse in the middle of a desert.
The thermal load, just the sheer amount of heat generated by that density of computation is massive. Density is the enemy here.
Because if you don't aggressively and constantly remove that heat, the silicon literally melts itself.
Which means these data centers aren't just consumers of electricity for the sake of running the computers. A massive percentage of that power goes strictly toward industrial-scale cooling.
We're talking colossal HVAC systems.
Massive water cooling towers on the roofs.
Millions of gallons of water constantly circulating just to keep the servers from triggering their automatic safety shutdowns.
And this is exactly where the psychological blind spot the source mentions really comes into play. We use terms like wireless and cloud computing,
which neatly strip away all the physical associations of heavy industry.
But those concrete buildings are there. They are anchored to the earth, and they are consuming colossal amounts of physical resources every single second.
They are a physical tether to our seemingly untethered digital lives.
And because they are so massive, and because they are so absolutely critical to everything we do, they present a completely new kind of problem.
Right.
Because when we usually think about threats to our data, our minds immediately go to the digital realm. We worry about the things we see in the headlines.
State-sponsored hackers.
Sophisticated ransomware shutting down pipelines, or malicious code sneaking past a firewall.
We have been conditioned to believe that because our data lives in a digital space, the only way to compromise that data is through digital means.
Exactly. We assume the battlefield is entirely comprised of code, encryption keys, and zero-day exploits.
The assumption is that if a hostile actor wants to disrupt our economy or steal critical intelligence, they have to outsmart an army of elite software engineers.
Here's where it gets really interesting. Because the new reality of modern warfare, according to our source material, is flipping that entire assumption upside down.
We are seeing a profound shift from cyber warfare to kinetic physical warfare directed at digital assets.
It is a deeply uncomfortable pivot in tactical thinking.
It is. Because these data centers are massive physical buildings that require constant power and constant cooling, they have inevitably become massive physical targets.
You do not need to spend months writing a million lines of malicious code to bypass a firewall.
Not if you can just physically destroy the building the server sits in.
And the source provides a highly specific and frankly alarming example of this actually happening. We are not talking about theoretical war games in a Pentagon basement here.
No, there are physical attacks occurring right now.
The text specifically highlights drone strikes that have been targeting AWS Amazon Web Services data centers in the Gulf region.
Let's really analyze the mechanics of that for a moment. AWS is the backbone for a massive portion of the global internet.
Countless businesses, government agencies, streaming services, they all rely on it.
And it is being targeted not by anonymous hackers deploying a virus, but by literal physical drone strikes.
And when you place that in the context of the Gulf region, an area with incredibly high ambient temperatures where cooling is already working overtime, the threat vector becomes incredibly clear.
When you hear about drone strikes, you typically think of traditional military conflicts, supply chains, weapons depots, troop movements.
You don't think about the physical warehouse where your company's database or your family's media library is stored.
But the tactical logic behind these attacks is almost breathtaking in its brutal efficiency.
It's entirely about asymmetry.
Exactly. Why would a hostile nation or a rogue group bother spending tens of millions of dollars and years of specialized research to try and hack through a constantly updating, incredibly secure digital defense system?
Right. Why try to outsmart the best cybersecurity minds and AI threat detection algorithms in the world?
When you can achieve the exact same destructive result, a complete denial of service, simply by flying a relatively cheap drone into the building's external water chillers.
It's like finding the exhaust port on the Death Star. We build these impenetrable digital fortresses. We protect them with the most advanced 256-bit encryption known to humanity.
Layers upon layers of digital security, biometric access, and software redundancy.
And yet the Achilles heel of the entire operation is just the air conditioner on the roof.
It sounds absurd when we distill it down to the air conditioner, but it is the absolute truth of hyperscale engineering.
If you take out the cooling towers, or if you manage to sever the connection to the local power substation, thermal runaway happens incredibly fast.
You don't need to decrypt a single file.
You don't need a single password.
The servers overheat, the safety protocols trigger to prevent a literal fire, and the entire system shuts itself down.
And the source material paints such a striking image of what happens the moment those safety protocols trigger.
It really does.
The author notes that if you successfully execute that physical attack, all of that incredible world-changing technology instantly becomes nothing more than a very expensive, very quiet room.
That phrasing perfectly captures the gravity of the situation. A very expensive, very quiet room.
If you have ever stood inside a functioning data center, the noise is the first thing that hits you.
It is the roar of industrial fans, the constant deafening hum of millions of processors routing global traffic.
It is the literal sound of the global economy functioning. And with one successful physical strike, all of that noise stops.
And the silence of that room would echo across the entire world.
Because in that silence, global supply chains freeze. In that silence, your medical records cannot be accessed by an emergency room doctor.
In that silence, the banking system halts.
That is the vulnerability of power. We have placed all of our digital eggs into these incredibly fragile, extremely hot concrete baskets.
If we connect this to the bigger picture, we have to realize that it is not just our current digital economy at stake here.
The source material makes a compelling argument that the stakes are exponentially higher when we look at the horizon of technology.
Specifically, the entire future of global AI development is precariously resting inside these vulnerable physical structures.
The AI development angle is huge. We hear constantly about the race for artificial intelligence. We hear about large language models, the sophisticated algorithms, the massive data sets being scraped from the internet.
But we treat it purely as a software achievement.
The reality is that training these AI models requires staggering amounts of physical compute power.
Precisely. AI is an industrial manufacturing process. Training a next-generation neural network doesn't just require a few smart programmers.
It requires tens of thousands of advanced GPUs running at maximum capacity for months at a time.
The power draw and the thermal output for AI data centers are significantly higher than standard web hosting facilities. We are talking about power requirements jumping from megawatts to gigawatts.
Which means the nation that controls and physically protects its data centers is the nation that controls the future of AI.
If an adversary wants to kneecap a rival country's AI advancements, they don't need to infiltrate their network and steal the source code of the algorithm.
They just need to turn those processing centers into expensive, quiet rooms.
Without reliable electricity and without massive industrial cooling, the entire digital ecosystem, from the most advanced artificial general intelligence down to your personal email, simply grinds to a halt.
And this vulnerability fundamentally alters the geopolitical landscape.
Nations are beginning to wake up to the fact that their economic security, their technological supremacy, and their national defense are no longer just about protecting physical borders or securing airspace over cities.
It is now entirely about protecting the physical infrastructure of the digital world. The lines between cyber defense and physical defense have completely dissolved.
It's a massive house of cards. We have built the most advanced, complex, and interconnected digital civilization in human history.
And we have propped it all up on the blind assumption that the power grid will always deliver and the cooling fans will always spin.
We have treated these buildings like they are invisible, right up until the moment a drone strike reminds us that they are very real, very heavy, and very vulnerable.
Which forces a completely new strategic calculus.
For decades, tech companies built these data centers based on cheap land, proximity to fiber optic trunks, and access to cheap electricity and water.
They built them in open industrial parks. Security meant a chain link fence and a badge reader.
But when you introduce asymmetric kinetic warfare into the equation, that model is obsolete.
So what does this all mean?
It means we are entering a radically new era of infrastructure security. The grand takeaway from our source material is unambiguous.
If nations truly want to protect their AI advancements, and if they want to secure their digital economies against these emerging, highly physical threats, the entire paradigm must shift.
Relying on digital security and firewalls is no longer sufficient.
The conclusion drawn by the author is stark. Nations and tech conglomerates must start physically defending these massive concrete data centers exactly the same way they defend highly secure classified military bases.
The militarization of the internet's physical root. We have to stop viewing data centers as just commercial warehouses run by tech monopolies.
And start viewing them as critical national security assets on par with nuclear power plants or strategic missile silos.
Think about what a highly secure military base actually looks like. It's not just a fence and a guard shack.
You have layered perimeter defenses, heavily armed security personnel, and strict airspace restrictions.
But more importantly, you have anti-aircraft systems, advanced drone jamming technology, and hardened physical structures designed with blast walls to withstand kinetic attacks.
That is the level of physical defense the source is arguing is now fundamentally necessary for the buildings that hold our digital lives.
It is a profound reimagining of the internet. The internet was built on open protocols, resilience through routing, and commercial infrastructure.
It was designed to survive a nuclear strike by being decentralized.
But the physical nodes that make up that decentralization have become too massive, too centralized by a few key players, and too critical.
The drone strikes on AWS in the Gulf are not a bizarre anomaly. They are a preview of the future of warfare.
It is absolutely wild to imagine you drive past a data center today, and it usually just looks like a boring, windowless office park building.
You'd never look twice at it.
But the argument here is that tomorrow, that exact same building might need Patriot missile batteries on the roof and localized radar systems just to make sure you can still log into your banking app and verify a transaction.
It's a lot to wrap your head around.
This raises an important question.
Well, let's hear it.
If data centers are effectively becoming the new military bases, and if their power and cooling signatures make them such massive, easily identifiable targets for modern asymmetric warfare, will the tech companies of the near future be forced to abandon the surface entirely?
Wait, you mean?
Will they have to build our clouds deep underground, in secret, classified subterranean bunkers, just to keep our digital economy safe from a drone strike?
Wow. Just let that sink in for a moment. Instead of a weightless mist floating up in the sky, The future of the cloud might be a subterranean bunker, buried under a mountain, surrounded by classified military defenses and blast doors.
Also, we can keep our everyday digital lives running without interruption.
That is a completely different world than the one we thought we were living in when we woke up this morning.
It really is.
Well, thank you so much for joining us on this deep dive. We hope we achieved our mission today. The next time you take a photo on your phone and watch the loading bar as it backs up to the mist, we encourage you to think differently about the heavy, concrete, and highly vulnerable reality waiting for it on the other side.